73 seconds passed between liftoff and the moment the Space Shuttle Challenger broke apart over the Atlantic Ocean, off the coast of Cape Canaveral, Florida. 7 people were on board: a commander, a pilot, 4 mission specialists, and a high school teacher from Concord, New Hampshire, named Christa McAuliffe, who had been chosen from 11,000 applicants to become the first ordinary civilian NASA sent towards space. It was the morning of January 28, 1986, and millions of schoolchildren were watching the launch live in their classrooms. The vehicle came apart because a rubber seal failed in the cold, and the engineers who built that seal had spent the night before the launch urging NASA not to fly. The shuttle's 2 solid rocket boosters were built in sections and stacked on top of one another, and where those segments met, there was a joint. To keep the burning gas inside the rocket from escaping through that seam, engineers used a pair of rubber rings called O-rings. The ring sits in the gap, the rocket pressurizes, and the ring squeezes tight to seal the joint, much like the rubber gasket on a mason jar. The system depends on that rubber staying flexible enough to flex and snap back in a fraction of a second. Rubber stiffens in the cold. On the morning of the launch, the air temperature at the Kennedy Space Center was 36 degrees Fahrenheit, 15 degrees colder than any shuttle launch before it. On the booster joint that failed, sitting in the shade, the Rogers Commission later estimated the temperature was closer to 28 degrees. The engineers who built the boosters had set 53 degrees as their limit for how cold was safe, and the launch went ahead at less than half of that. The concern had been building for months. A Morton Thiokol engineer named Roger Boisjoli, one of the company's specialists on those seals, had written a memo in July of 1985 warning his managers that failing to fix the joint could produce, in his words, a catastrophe of the highest order, the loss of human life. That October, another engineer, Bob Ebeling, sent a memo to get management's attention and titled it "Help." On the evening of January 27th, the night before the launch, Thiokol engineers in Utah and NASA managers in Alabama and Florida joined a conference call to discuss the cold. The engineers recommended against launching. They argued that the cold would keep the seals from doing their job. NASA pushed back and asked for proof that the seals would fail, which reversed the usual logic of the decision. Instead of proving the launch was safe, the engineers were now being asked to prove it would fail, and no engineer could name the exact second a seal would give way. Thiokol's managers took the call offline to confer among themselves. According to later testimony, a senior vice president at Thiokol named Gerald Mason turned to his vice president of engineering, Bob Lund, and told him to take off his engineering hat and put on his management hat. The recommendation then shifted from "do not launch" to "launch." The engineers who knew the seals best were not asked to sign it, and some refused. Alan MacDonald, who directed the booster project, would not put his name on the launch approval. NASA received the approval and did not ask why the answer had changed. At 38 minutes past 11, Challenger left the pad. Less than a second into the flight, cameras recorded puffs of dark grey smoke coming off that joint, meaning the seal had already failed at ignition. For a short time, debris from the burning fuel plugged the leak and the shuttle kept climbing. It then hit a patch of high-altitude wind. The plug broke loose, and a jet of flame began cutting into the external fuel tank. 73 seconds after liftoff, the flight was over. A presidential commission was formed to determine what happened, and among its members was the physicist Richard Feynman. During a televised hearing on February 11, 1986, Feynman took a piece of the O-ring rubber, clamped it, and dropped it into a glass of ice water. When he pulled it out and released the clamp, the rubber stayed compressed instead of springing back, demonstrating that the seal lost its resilience in the cold, which was the same failure the Thiokol engineers had warned about for months. Feynman also examined how NASA assessed risk. He asked the agency's managers what they believed the odds were of a catastrophic failure that would destroy a shuttle and its crew. Management put the figure at 1 in 100,000, while the working engineers estimated closer to 1 in 100, a thousand-fold gap between the people approving the launches and the people who built the rockets. On the practice of flying with a known flaw because earlier flights had survived it, Feynman said, "Try playing Russian roulette that way." The Rogers Commission delivered its report that June. It identified the cause as the failure of the pressure seal in the aft field joint of the right booster, a design the Commission described as unacceptably sensitive to temperature, among other factors. The shuttle program was grounded for 32 months while the joint was redesigned. The revised design added a third O-ring and built-in heaters to keep the seals from freezing on the launch pad. President Reagan addressed the country the evening of the disaster and said the crew had slipped the surly bonds of earth to touch the face of God, a line written by the speechwriter Peggy Noonan. The record is straightforward. 7 people died because a rubber seal could not do its job in the cold, and the people who built it knew it could not. They said so in writing months in advance and again by phone hours before the launch. They were told to take off their engineering hats and the launch went ahead. The seal did not fail because no one understood it. It failed because the people who understood it best were overruled by the people responsible for the schedule.